So, I'm gonna start with my introduction. Firstly, I'm Kamna Mishra from IIT Mandi, and currently I'm doing PhD in statistics, and I'm here for as your TA guide for probability and statistics. And the instructor of this course is Professor Sumesh Kumar from IIT Kharagpur. So, if you have any doubts, you can ask me in the middle or whenever you think it's comfortable for you. So, let's just start from the first question. Okay. So, my screen is visible to you, right? Yeah. Okay. So, the first question, okay, so today's class is basically on the distribution, continuous, and firstly, I will go through the what to say continuous distribution and discrete distribution. So we will start from the uniform distribution and then we will go to Poisson and then exponential. And normal is not done yet, so we will do that in next class. So the most basic distribution is uniform distribution, and here this distribution is uniformly between 4 to 7 hours. So the question is that we have a game, and the duration of all the games by one team in one season of Major Baseball League is seen to be ranged uniformly. So we can see that it is given that uniformly between this and this hour. Now we want to find the probability that team will play between this and this hour. So when we do this in probability in uniform distribution, so uniform distribution can be discrete or can be uh, continuous. So if you have like uniform distribution like 0 to 9, it is continuous, okay. But if you have uniform distribution, let's say integer 0 to 9, then it is not continuous, it is discrete. In this uniform distribution you have points at 0, 1, 2 up to 9. So this one is discrete and this one is continuous. Now here we have given a uniformly between 4 to 7 to 504 hours. When you say hour, then here, sorry. So now we need to find the probability. So probability that the team will play between 479 to 498. So the total time we have, we find it by b minus a. Okay, so it will be 504 minus 427, and in the above we have 498 minus 479. Let's say just you have this much of range and you want to find the probability of using this range. So it will be total divide. It will be this small range divided by the total range. So 498 minus 479, you can find it, and you can solve it. So after solving, it will be 19 by 77, which will be 0.0247. So this will be the answer. If you have any doubt, you can ask. Okay. So we will move to the next question. Uh, what is given here is that assume that the time taken to finish a standard sized piece of a cake by a 9-year-old child is uniformly distributed between zero point 0.5 to 3 minutes. So zero point 0.5 to 3 minutes, it is again given uniformly, and zero point 0.5 to 3 minutes. So it is continuous, okay? Because it can take any time like zero point 0.5 to zero point 0.6 minutes, zero point 0.7, 0.72. So it is basically continuous. So the distribution here is uniformly continuous distribution, and it is distributed between zero point 0.5 to 3. This is its range. So we write it as this, uh, that x we have, then it is uniformly distributed between zero point 0.5 to 3. Now we have the question is that given that a child has been eating the cake for more than 1.5 minutes, determine the probability that he or she will finish it in more than 2 minutes. So what is given here is that x, let's say x is the time taken by child finish the cake. So what given here is that this is known. Okay, the child that the child has been eating the cake for more than 1.5 minutes. So this is given, and now we want to find the probability that he or she will finish it in more than 2 minutes. So it will be probability of x greater than 2 given x greater than 1.5. So this is how we write it as probability of b by a. So if a is given, then we want to find the b, then we write it in this way. Okay. So what will be the answer? Now probability x is greater than 2. X is greater than 2, how we will find it? Uh, X is greater than 2 means it will be between 2 to 3. So it will be 3 minus 2 and divided by, like we did it here. So it will be 2 to 3 divided by the whole range. So it will be 3 minus 2 divided by the whole range, which is 3 minus 0.5. Whole divided by, it is greater than 1.5, so it will be 3 minus 1.5, and it is divided by 3 minus 0.5. So this is the probability that a child will eat the cake more than 5 minutes, more than 1.5 minutes, and this is in more than 2 minutes. So now we can solve it. It will be 1 divided by 2.5 whole divided by 1.5 divided by 2.5. This will be cancelled out. So it will be 10 by 15, and 10 by 15 will be 2 by 3. So this will be this. Okay. Now we move to the next question. So firstly we will check what is the distribution it is following. So given here is that the number of phone calls over a certain period of time follows the uh, Poisson distribution. So it follows Poisson distribution. So what is the average number of call necessary for the probability of one or more calls? So when it follows Poisson distribution, then the probability of x is equal to x is e to the power minus lambda x minus lambda to the power x divided by x factor. So now what we need to find is that probability that one or more cause. Probability that one or more cause, so x is greater than or equal to 1. So whenever we have that probability of one or more, or at least one, or any kind of this, then what do we do is that we simply take it as 1 minus probability of no cause, because then we cannot find that probability of one call, then two call, and then three, and then we cannot do it in this way. So that's why we take even if we can do it. Like even if we have that uh, x is in between 0 to 4, and then we need to find probability of x greater than or equal to 1. Then also what we do is that we take 1 minus probability that x is equal to 0. So probability of no cause means probability of x is equal to 0. So, so when x is equal to 0, lambda to the power x will be 0, sorry 1, lambda to the power 0, and it will be 1 factorial. So it will be 1 minus e to the power minus lambda. So its probability given here is that 0.98. So it will be 0.02 is equal to e to the power minus lambda, and then minus lambda will be ln of 0.02, which will be ln 2 minus, I don't know, so we can solve it. Ln 0.0. it, it is approximately minus 3.91. So lambda will be 3.91, approximately 4. So this is the average number of cause necessary for the probability of one or more cause is at least 0.98. Okay. And then why do we say that lambda, what we get here, that is the average number of cause? Because for Poisson distribution, for Poisson distribution, expectation of x or mu, or you want to say mean or average, this is equal to lambda. So if lambda is 3.91 or approximately 4, then this lambda, this is the average number of curves. So next question we have here is that a Poisson process governs a website hit with a mean of 20 hour, and now we want to find the probability that there won't be any hits on their website for a 12-minute week. So firstly, again the question is based on the Poisson distribution, and the given here is that we can take like the probability that their mean of 20 every hour. So mean is given here. Mean is what? Mean is lambda. So mean is lambda, and now we can take x as time in hour from the start of interval until the first hit. So now we want to find its probability x greater than, this is 12 by 20. So 12-minute period. It is means this. So 12 by 60, it will be point 5. No, it will be 1 upon 5, will be point 2. So it will be x greater than point 2. So it will be 1 minus f of 0.2, and it will be 1 minus e to the power minus lambda x. So lambda is 20 and x is 1. So that will be the answer. So uh, uh, me tell you how to find this expectation if the basic formula when as Poisson distribution is discrete distribution. Okay, so Poisson distribution is discrete one. So in the time of discrete one, how do we find the expectation? We find the expectation of x by using x fx. Okay. Now, if x is here, then it will be here. So if we have expectation of 1 upon 1 plus x, then it will be summation 1 upon 1 plus x fx. So px is equal to x we have given here, and it is x is from 0 to infinity. Now this is very important that x is from 0 to infinity, because here it is given as x from 1 to 3 and so on. But x is equal to 0 also satisfy this condition. So x is equal to 0 also we need to take when we are trying to find this expectation of 1 upon 1 by x, because it will lead to a different answer. Okay. So now what will be the expectation of 1 upon 1 plus x? It will be summation x is equal to 0 to infinity 1 upon x plus 1, and then fx. Now it is given here from 1 to 3 and all. So here we will take from 1 to 3 and all, and then we will subtract this 0 part. So this and fx given here is that 1 upon 1 minus e to the power minus lambda, and then e to the power minus lambda, lambda to the power x, and then x capital. Now this is a constant term, there is no x here, so we can take it out. So we can take this one, this part out, and then we will start summation from here. So what will happen is the expectation of 1 upon 1 plus x will be 1 upon 1 minus e to the power minus lambda, and it will be summation x is equal to 1 to infinity e to the power minus lambda, lambda to the power x by x factorial 1 upon x plus 1. Now x plus 1 times, sorry, this one is also constant, we can take this out also, e to the power minus lambda. Now x plus 1 we can take it by here, and then e to the power minus lambda 1 upon. What we can do here is that summation x is equal to 1 to infinity lambda to the power x, and then x plus 1 factorial. Now we want to write this in terms of e to the power lambda, because if you know the expression of e to the power lambda, it goes something like this: 1 plus lambda square upon 2. So what we will do here is that we can just, and then we will put 1 lambda here. This all we are trying to do is that we are trying to make this in terms of e to the power lambda. So if you may know the series, then so e to the power lambda series is 1 plus lambda square upon 2 plus lambda cube upon 3, and then so on. So we have series like this. If we put lambda 1, then it will be lambda square divided by 2 factorial. So we don't have this part. Okay. If we put x is equal to 2, it will be lambda cube divided by 3 factorial, and then lambda to the power, sorry, this is better. Okay, and then lambda to the power 4 by 4 factorial, lambda to the power 5 by 5 factorial. So this is the part we don't have. So what we will do is that we will add this part, and then we will subtract this part. So ultimately we will have e to the power minus lambda 1 minus e to the power minus lambda times lambda, and it will be summation x is equal to minus 1 to infinity lambda to the power x plus 1 divided by x plus 1 factorial minus 1 minus lambda. So what I did here is that I have put the limit x is equal to minus 1. So when x is equal to minus 1, it will be lambda to the power 0 divided by 0 factorial, which will be 1. So I have added this 1 and I have subtracted this 1. Similarly, when x is equal to 0, it will be a lambda to the power 0 plus 1, which will be 1. So lambda to the power 1 divided by 0 plus 1, that means 1 factorial. So it will be lambda to the power 1 by 1 factorial. So I have added this lambda and I have subtracted this lambda again. In the next, it will be x is equal to 1. So 1 to infinity we already had, so there is nothing to subtract anymore. Now we have this equation, and then sorry, this expression, and then this expression can be written as e to the power lambda. So in place of this we can write e to the power lambda. So what it ultimately we will have e to the power minus lambda divided by lambda 1 minus e to the power minus lambda, and then it will be e to the power lambda minus 1 minus lambda. Okay, so but now you can see there is no e to the inside expression we have e to the power minus lambda minus 1 minus lambda. This one we have in b part, but the dividing expression what we will do is that e to the power minus lambda we can write it as 1 upon e to the power lambda, right? E to the power minus lambda we can write it as 1 upon e to the power lambda. So we will just do that, and it will be 1 upon lambda, and it will be e to the power lambda minus 1 minus. So that will be your final answer. So we will. Okay. Do you have any question? It was a little bit tough or maybe lengthy. So next we will move to part that what is given here is that 4% pens produced by a company are defective. Okay, 4% pen we have a company make are defective, and then pens are packed in a boxes of okay, in a box which contains 150 pen. Now what we have here is it is fail. The company gives the guarantee that at most two pens in a box will be defective. Now we need to do the Poisson approximation to binomial. Okay, we can do it by binomial also, but what happens is that when you have this, like this is 150, but then if you have like 1000 number, then it will be tough to do the binomial, because it will be tough to find the factorial in that. Like if we want to find like 1000 c10, it will be very tough. So what we do is that we do the Poisson approximation to the binomial, and then we try to find the probability that a box will fail to meet the guarantee. So what we have here is that we have 4% pens are defective. So 4% pens are defective means we have total of 150 pens, and 4% pen are defective. That means 4% of it. So we will have 4 into 150 divided by 100. So it will be 3, 2, and 6. So what we have here is that 6 pens are defective. So now probability that a box will fail to meet the guarantee. What is the guarantee? It is that at most 2 pens in a box will be defective. So if it will fail, that means the box have greater than 2 pens which are defective. So let x be the number of defective pens in a box. So if it will fail to meet the guarantee, then we need to find the probability that x is greater than 2. Now it will be 1 minus probability x is less than or equal to. Now once you understand the question, it is very easy to formulate it, and once you formulate it, all you need to do is that put the values. So I will again write it be x is equal to x is e to the power minus lambda, lambda to the power x divided by x factorial. This is the formula for question. So x less than or equal to 2 means x is equal to 0 plus x is equal to 1 plus x is equal to 2. Now e to the power minus lambda is a constant. Okay, so lambda is 6 here. So e to the power minus lambda, we can take it out. So it will be 1 minus e to the power lambda, which is e to the power, sorry, minus lambda, which will be e to the power minus 6. And then when x is equal to 0, lambda to the power x will be 1. Simple. When x is equal to 1, it will be lambda. Lambda given here is 6. So it will be 6 to the power 1 by 1. Then px is equal to 2. So x is equal to 2. It will be 6 square by 2. So now this will be 1 plus 6, and then it will be 36 by 2, which will be 18. So 18 plus 6 will be 24, and then 1 will be 25. So it will be 1 minus 25 e to the power minus 6. So this will be this. Now the next question we have here is that let x be the Poisson random variable with the parameter lambda, and px is equal to 0 is equal plus px is equal to 2 is equal to 2px is equal to 1. So we have parameter lambda, we have Poisson distribution as this, and then we have this equation given, and at last we need to find what is x greater than 2. So by using this equation, we will find what is the value of lambda parameter, and then after that we will put that value as 1 minus px less than equal to. So first step is that when x is equal to 0, it will be 1. when x is equal to 2, it will be e to the power minus lambda, and then lambda to the 2 e to the power minus lambda. Sorry, it will be 1 e to the power minus lambda to the power minus lambda. Lambda is square by 2 factorial, and then is equal to will be 2 times lambda to the power 1, right? Times e to the power minus lambda divided by 1 factorial. So e to the power minus lambda, this is not equal to 0, so we can cancel out. If it can be equal to 0, we cannot cancel out. So we can cancel out this, and then it will be 1 plus lambda square is equal to 2 lambda. So it will be lambda square minus 2 lambda plus 1 is equal to 0. So lambda is equal to 1. Now we need to find what is px greater than 2. So it will be 1 minus px less than or equal to 2. This will be 1 minus p x is equal to 0, x is equal to 1, and then x is equal to 2. So which will be further 1 minus, and then px is equal to 0, 1, 2. So e to the power minus lambda will be the common one. So e to the power minus 1 will be common, and then x is equal to 0, it will be 1. X is equal to x is equal to 1, x is equal to 1. If you put, it will be 1 to the power 1 by 1 factorial, again 1, and then x is equal to 2, it will be 1 to the power 2 by 2 factorial, so it will be 1 upon 2. So total will be 1, 2, 2 plus half will be 5 upon 2. So it will be 1 minus 5 upon 2 e to the power minus. So this will be so we have done enough of questions on Poisson distribution. If you have any doubt regarding the Poisson distribution or how we are using this, why, then you can ask. Okay, so next question we have here is that with an average of 10,000 miles, the number of miles a particular car may travel before experiencing battery failure is exponentially distributed, and the uh, car's owner need uh, needs to travel 4,000 miles. What is the probability that journey can be finished without any issue, without a car battery replacement? So, what is given here is that there's a car and its battery failure is generally happens after 10,000 miles. So, uh, if a person wants to travel just 4,000 miles, what is the probability that that person does not need a car battery replacement? So that probability must be low because it works 10,000 miles without any issues. Now, given here is that it is exponentially distributed. So, exponentially distributed, firstly, the exponential distribution is a continuous distribution. So, exponential distribution is continuous distribution. Now, fx, its PDF is given by lambda e to the power minus lambda x. And its capital fx is 1 minus e to the power minus lambda x. When x is greater than 0 and it will be 0 when x is less than 0. Now, if this part is basically x less than or equal to x. So if we want to find probability of x greater than x, small x, then it will be 1 minus e to the power minus lambda x, which will be e to the power minus lambda x. So now we will move to the question that the car owner needs to travel 4,000 miles, and we need to find the probability that journey can be finished without the battery replacement. So what is given here is that 4,000 miles. That means if car can travel more than 4,000 miles, then it does not need the battery replacement in the middle. In the time of continuous distribution, we do not find the probability at a single point, because in the time of continuous distribution, the probability at a point is 0. So if the car's owner needs to travel 4,000 miles, then what we do is that we try to find the probability that x is greater than 4,000. That means if car can travel uh, greater than or more than 4,000 miles, then it means that it will not need any battery replacement in the middle. Okay. So it will be px greater than 4,000. So and lambda given here is that 10,000 miles. So it will be 1, sorry, it will be e to the power minus x, and it lambda is, sorry, I'm sorry. In the time of exponential distribution, the average is 1 upon lambda. So if this is lambda e to the power minus lambda, then expectation of x is uh, 1 upon lambda. Okay. So average given here is that 10,000 miles. So lambda will be 1 upon 10,000. So it will be 1 upon 10,000 will be minus 4 upon 10, which will be minus 2 upon 5. So it will be point. So this will be the answer. Okay. So the next question we have here is that the time need to solve a problem as an exponential distribution with lambda is equal to 1 by 3. Now two students start tackling the problem simultaneously, and we are assuming that students are working independently on their own. So at the end of 2 minutes, what is the probability that at least one student has figured out how to solve the problem? So what is given here is that lambda is equal to 1 by 3 is given. So uh, fx we have is 1 by 3 lambda e to the power minus lambda x uh, minus x by 3. Now we need to find that at least at the end of 2 minutes, what is the probability that at least one student had figured out. So we will find it firstly for the first person and the second person, and then uh, probability that at least one. Again, we have a question like this, that at least one will be 1 minus probability that no one has solved the problem in 2 sorry, in 2 minutes. Now, no one has solved the problem in 2 minutes. That means the person has taken more than 2 minutes to solve that problem. So both of the students has taken 2 minutes, more than 2 minutes to solve that problem. So what it will be, we will firstly find this separately, and then we will put the value. So probability that uh, let x be the person or x be the student who is solving the problem, and it is taking time more than 2. So it will be 2 to infinity and 1 by 3 e to the power minus x upon 3 dx. So this is the simple integration. I want you to solve this. Can you solve this integration? You can do it directly also, like e to the power minus ax will be e to the power minus ax divided by minus a, or you can do it as x by 3 is equal to y and then x is equal to 3y. So solve this and uh, let me know the answer. Like, I'll give you 2-3 minutes to solve this. If you have solved it, then just let me know the answer. And it has nothing to do with probability, it is simple integration. So that will be 1 upon 3 will be constant, it will come out. It will be e to the power minus x upon 3 divided by minus 1 upon 3, and then we will put the limit in between 0 to infinity. So 1 upon 3, 1 upon 3 will be cancelled out, it will be minus. So ultimately we will have minus e to the power minus infinity plus e to the power 0, right? Sorry, 2, e to the power minus 2 by 3. So e to the power minus infinity is 1 upon e to the power infinity. So e to the power infinity is uh, infinity. So e to the power minus infinity will be 1 upon e to the power infinity, which will be 1 upon infinity, which will be 0. So that part is 0, and then this part will be e to the power minus 2 upon 3. So e to the power minus 2 upon 3 is the probability that one student has not figured out the problem. Now, what is given here is that students are working independently on their own. When they are working independently, then the probability that no one has solved the problem will be equal to probability that first student has not solved the problem multiply by probability that second student has not solved the problem. So for the first one it is e to the power minus 2 by 3. For the second one also it is e to the power minus 2 by 3. So this will be 1 minus e to the power minus 2 by 3 whole is, so it will be 1 minus. Anybody wants to say something? Huh? It will be 0.264 approximately minus 1 will be 0.736. So that will be the answer. Is it okay, everyone? So next question we have here is that in a supercomputer system, CPU cooling is controlled by electronically driven fans. You all know that most probably. If you have any laptop or like system, then CPU cooling is controlled by the fans it has. Now, given here is that assume that the lifetime T in weeks of a fan can be modeled by exponential distribution. So, lifetime generally, when you see the problems like lifetime of a bulb or lifetime of a car battery or lifetime of any fan or whatsoever, generally it happens to be that it follows the exponential distribution. It is not that it will always follow exponential distribution, but there is like high chance that it follows the exponential distribution. Okay. And the parameter given here is that lambda is equal to 0.002. Now we want to find the probability that a fan will be working even, that is not even, it is even after 1,000 weeks. So given here is that lambda is equal to 0.002. Okay, and probability of x greater than 1,000. So what I have said earlier here is that if in time of exponential distribution we need to find the probability that x greater than x, that is equal to e to the power minus lambda x. So it will be e to the power minus lambda x. So minus lambda given here is that 0.002, and x given here is that 1000. So if you will just multiply, it will be e to the power minus 1. Like this equation. Okay. Okay. Now this is a bit lengthy question, and you need to be a bit focused in this also, because it will have the integration also. It does not have an integration. That one is a different question. Okay, so what is given here is that a series system has three independent components. Now you need to understand two things. Is there an issue? So if you have a system, so there is a chance. There is a thing that either the components are in series system or in parallel system. So in series system, what happens is that components are like this, and in parallel, it is like this. So this one is series, this one is parallel. So the difference is that in series, what happens is that if this one is not working, then this or this work or doesn't work. It really doesn't matter. Okay. If this is not working, let's say we have some input here, we have some output here, we have some input here, we have some output. Okay. If this is not working, then it doesn't matter this or this one is working or not. Ultimately, output will be zero. Okay. So what happens is that if you have a system which is in series, so if any of the components fail, then the whole whole system fails. Okay. In parallel, it does not happen. So if you have, let's say, five appliances in your home, and they all are connected in parallel, so if one fails, then other four works very well. It does not affect the other, and it does not affect the output of the whole system. So in the parallel, it happens that if this system fails, what will happen is that input will go and then output will come. Okay. So whenever series is given, so you need to take care of that. That if one system, one component fails, then the system fails. Now given here is that series system has three independent components. So that means they are independent. That their probability of failing will be independent. Now the lifetime of xi of ith component is exponentially distributed with the parameter lambda is equal to 1 upon I. So if the system has failed before the time, then the probability that failure was caused by only second time. So what is given here is that the lifetime xi of ith component is distributed, exponentially distributed with parameter lambda is equal to 1 upon. So for the first one, lifetime is 1. Second one, it is 1 upon 2. And third one, it is 1 upon 3. So x1 follows exponential 1, x2 follows exponential 1 upon 2, and x3 follows exponential 1 upon 3. Now, probability, it is something like base theorem. Probability that failure was caused by only second component, which means that system is failed. We have given that system is failed, and then we want to find the probability that it happened because of the second component. So this is what we have learned in the base theorem, that if this is happened, what is the probability that this happening is caused by a particular one. So firstly we will find what is the probability that system fails. Now, since it is in series, so if system fails, that means system can be failed by first component, second component, third component. It may happen that first and second, second and third and first, and then at last 1, 2, 3. So, what we will do is that if we if we will find that 1 minus probability that no component. Okay. So if no component fail, then only system will work. Otherwise, system will not work. So it will be 1 minus probability that no component fail. So lifetime is lambda. So exponential distributed. So no component fail means it will be e to the power minus lambda x. That means it is probability of x greater than or equal to x. So e to the power minus lambda x, and no component fail. Okay, so it will be e to the power minus x into e to the power minus x upon 2 into e to the power minus x upon 3. Okay, just e to the power minus lambda x for second one and minus lambda x for third one. So it will be 1 minus e to the power, and you can sum it. So it will be 3 to 6, 6 will be here, minus will come out, and it will be 6 plus 3 plus 6, 3, 9 plus 2, 11. 9 x. So it will be 1 minus e to the power minus 11 upon 6 x. Now, now we want to find the probability that it happened because of the second component. So probability that second component is divided by system points. Uh, Only, that is also mentioned here, that only second component fails. So only second component fails means first and third are working properly. So second component fails means that will be 1 minus e to the power x. So first component is working fine, third component is working fine, just first component fails, that means 1 upon e to the power minus x divided by 1 minus e to the power minus 11 upon 6, right? Then this will be the answer. It will be e to the power minus 4x upon 3. So you can write it as x or t, whatsoever you want. So it will be e to the power minus 4x upon 3, 1 minus e to the power minus t upon 2. In division, we have 1 minus e to the power 11 t by 6. So that will be. Is it okay? Okay. Next question given here is that a small shopping mall has 5 ACs. Okay. And the lifetime of an AC follows independent and identical exponential distribution. That means all the ACs are independent and they are identically following same distribution, exponential distribution, and its mean is 100 hours. So if all ACs are working simultaneously, then what is the probability that after 100 hours there are at least two ACs in working condition? So what do we have? We have five ACs, and then we want to find that it will work up to 100 hours. There is like average time is 100. It may work 100 plus, of course. So we need to find that at least two works after 100 hours also. So what given is here is that lambda is equal to, now mean is 100 hour. So in the terms time of exponential distribution, mean l- uh, l- sorry, lambda is equal to 1 upon mean, 1 upon expectation of x. So mean will be 1 upon 100. Okay, lambda. So now we want to find probability that x greater than or equal to 2 means x is equal to 0. X is equal to 0. X is equal to 0 means no AC works after 100 hours. Okay. So no AC works after 100 hours means it works till 100 hours. So it will be probability x less than or equal to x. Uh, or yes, let's say probability that t is less than 100. So what it will be? It will be and then for all five. Okay. So for all five. So for 100 hours it will work. It will be f100. Now probability t or x less than 100. What is it? It is 1 minus e to the power minus lambda x. So it will be 1 minus e to the power minus lambda here is 100, x here is 100 to the power 5. So it will be 1 minus e to the power minus 1 to the power 5. Now we need to find the probability that x is equal to 1. Now probability x is equal to 1 means one AC is working after 100 hour. Okay. So now that one AC can be any AC out of 5. So firstly we will have 5 C1. Okay. Next we will have 1 is greater than 100 and other 4 is less than 100. Right? So now that will be 5 times greater than 100, it will be e to the power minus 1, and less than 100 it will be again 1 minus e to the power minus 1 to the power 4. So that one will be probability of x is equal to. So probability of x greater than or equal to 2 will be 1 minus probability of x is equal to 0 was 1 is e to the power minus 1 to the power 5 and then minus will be 1 minus e to the power minus 1 upon 4 e to the power minus 1 n times. So now we need the answer in this form. So what we will do is that we will take this form 1 minus 1 upon e to the power 5 minus 1 minus 1 upon e to the power 4 1 upon e times 5 e to the power minus 5 will be 1 minus e to the power 5 e to the power 1 minus 4 will be common will be e to the power minus 1 minus plus e to the power minus 1 and then plus 5, right? So 5 minus 1 will be 4, so it will be e minus 1 power 4 e plus 4 divided by e to the power. So this will be the answer. Any doubts? Okay. So next question we have here is that a water tank supplier distributes 10 liters of drinking water per house per day. Now the consumption per house follows gamma distribution. So do you know what is gamma distribution? Gamma distribution. So gamma distribution is also a continuous distribution and it has value 0 when t less than 0 is equal to 0 and lambda to the power r t to the power r minus 1 e to the power minus lambda t divided by gamma r where t and r are greater than 0. So this is gamma distribution and its mean of gamma distribution is given by mu. Mean is given by r upon lambda and variance is given by r upon lambda. So what is given here is that mean is equal to 10 and then variance is equal to 50. So mu is 10. So r upon lambda is 10 and r upon lambda is square is 50. So we can divide it. If we will divide it, r upon lambda will be cancelled out. Lambda will go on the numerator. So lambda will be 1 upon, right? And if you put lambda 1 upon 5, then r will be 10 upon 5, which will be equal to. Now, what is the probability that supply is insufficient? So generally, it supplies 10 liters of drinking water. 10 liters of drinking water. If it is insufficient, that means uh, the supply it supplies less than 10 liters. So we need to find Px less than 10. So now we need to find the probability that x less than. So x less than 10, we have fx. So what we will do is that 0 to 10. Now the distribution here is lambda to the power r. It is 1 upon 5 square t to the power r minus 1. That means t to the power 2 minus 1 will be t. E to the power minus lambda t, e to the power minus 1 5 t, and then gamma t. So now you may know the function gamma function. Is there anybody who knows the gamma function? What is gamma function? Uh, okay, what is the value of gamma 2? Like gamma n if n is integer. Okay, so if n is integer, gamma n is equal to n minus 1 factorial. Uh, no, n minus 1. So if gamma 2 is 1, gamma 3 is 2. Simple. And if it is gamma like 3 by 2, it is 1 by 2 gamma 2. So yeah, that one is factorial. Okay. Now next is that gamma function in terms of integration. So uh, the integration 0 to infinity t e to the power minus t, uh, 0 to infinity t to the power n minus 1 e to the power minus t dt. This is what we call as gamma function, and that one is equal to gamma n. So we have similar kind of problem here. It just rather than 0 to infinity, it is 0 to 10. So what we will do is that we will subtract it 1 minus 10 to infinity, and then it will be 1 upon 5 square. Gamma 2 is 1, so we can neglect that. T e to the power minus t upon. So now we can take t to the power 5 as u. So t to the power T to the power 5 d by 5. D by 5 is equal to u. D is equal to 5 u, and d t by 5 is equal to du. Right? Next thing is that change of limit. So when t is equal to 10, t is equal to 10, that time u is equal to 10 upon 5, that will be 2. So it will convert to 1 minus 2 infinity. Because as infinity, when t is infinity, infinity upon 5 will also be infinity. 1 upon 5 is square. T is 5u e to the power minus u, and dt is 5d. So 5d. So 5 and 5 will be cancelled out by 1 by 5 square. So ultimately, it will be. Let me add one page. So that one will be 1 minus 2 infinity u e to the power minus u du. Now it is not 0, so we cannot directly use that function. What we will do is that we will do by parts. Does anybody know how to do the integration by parts? How many of you are from mathematics background? You, Himmat, you are not from mathematical. Okay, Kripa, you are from mathematics background. So you know this integration, right? This is, I think, in 12th class or something, I think. So can you do that? Answer me like yes or no. Uh, Mathematics, what? Like BSc or 12th? Basic. Okay, but then it is so simple. So okay, let me do one step and then you do the next step. So this would, yeah. So that one we will take. Yeah. So which one we will take as first? So that one will be e to the power minus u du, and then u will come out. Uh, we will put the limits afterwards, and then it will be e to the power minus u divided by 1. Okay, and then minus, it will be 2 to the power infinity, and this one will be du upon u will be 1. This that will be e to the power minus u du. Minus minus will be cancelled out again, and this one will be plus, and it will again be minus. So when we will put infinity, e to the power minus infinity will be 0. So that part will be 0. In the next part, it will be uh, 2 e to the power minus u. Right? And then for this, it will be e to the power minus e to the power minus u 2 to the 2 infinity will be 1 minus 2 e to the power minus u minus sorry, minus 2, and then it will be e to the power minus infinity will be 0, and then next one will be plus. Am I doing something wrong? in the second part, I have written u as multiplication because we apply limit to the whole. Yeah, so we did the integration. Yeah, we did the integration, but you know, when you do the integration, then also limit applies on the whole part. Otherwise, your answer will be what? 1 minus u e to the power minus 2. Okay, if you think in this way, what you can do is that just do the integration and then put the limits afterwards. If you think otherwise, this is what there is a what do we say? No, I don't remember the word, but if this has the limit, then its solving will not contain the variable u, isn't it? If you have any integration and you are putting the limits in the variable, then the answer will not be in terms of u. Is still any doubts? You can say if you have any doubt, but all I'm telling you is that when you do the integration, you put the limit, then you don't have variable at the end. So you put the limits on everything whatsoever integration you have at last. Is it okay? Okay, anyways, so this will be the answer, and I think there's I think there is some issue in the options. So answer is this: 1 minus e to the power 1 minus is not written here. So this will be the answer. Is it okay or not? At least say if it is okay. Just I will just move forward, right? Okay. 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 So what questions is it? Now, the question we have here is that the lifetime X of a bulb is following the Weber distribution. So let me just write the formula for the Weber distribution. So X follows Weber distribution with beta is equal to 3. So Zibble distribution basically have two parameters, alpha and beta, and the probability function is given by alpha beta x to the power beta minus 1 and e to the power minus alpha x beta, and it is 0 otherwise it is when x alpha beta all are greater than 0. So now what we have is that, so now what is given, uh, x follows the People distribution with beta is equal to 3, and then we have one condition given so that we can find the value of alpha. And sorry, this is after 2 months. There is some cutting. So now we want to find we have observed that the conditional probability that a component will be working after 3 months, given that it is working after 2 months, it is 19 upon 2. So what is given here is that uh, probability that x is greater than 3 months given x is greater than 2. So x is greater than 3 months. That means the component will be working after 3 months, and it is given that it is working after 2 months. So x is greater than 2. This is given. And what is it? It is e to the power minus 9. Right? Now, now for that we need to find that the probability x greater than t or x greater than x. So this is 1 minus fx or ft, whatever you want to say, and this is divided 1 minus to the power minus, just a minute. It is 1 minus 1 minus e to the power minus alpha x to the power beta. So when you will do the lectures, you will get all these formulae. So it will be basically e to the power minus alpha x to the power beta. So probability x greater than b will be e to the power minus alpha t to the power beta. So now x greater than 3 divided by x uh, greater than 2, it will be e to the power minus alpha, and the t given here is that 2. So 2 and beta is 3. Above it will be alpha 3 to the power 3, and it will be equal to e to the power minus 19. So that one will be 3 cube 27, 27 alpha and plus 8 alpha. Right? So it will be 90. Yeah, it will be minus 19 alpha. So it will be e to the power minus 19 upon 2. Alpha is equal to 1 upon 2. Now we need to find the probability that component is working after 2 months. So we need to find probability x greater than 2. So x greater than 2 will be simply e to the power minus alpha times 2 cube. So it will be e to the power minus half times 8 will be to the power minus. Is it okay? Any doubts? Now, what is given here is that the life of an MRI machine. The life of an MRI machine is modeled by Weber distribution with the CDF, which I have told you earlier, e to the power minus x to the power. Okay, so they have given in this form. Okay. X by delta to the power beta, and the parameters given here is that beta is equal to 3 and delta is equal to 700 hours. Then we need to find the probability that MRI fails before 350. So MRI fails before 350 means um, that lifetime will be less than 350. That is all we want to find. So probability x less than or equal to x is what? It is fx. So it is simply f and 350. Now you have every value is given. I think e minus x is 350, delta is 700, beta given here is 3. So it will be 1 minus e to the power minus will be 1 by 2. So it will be 1 upon. So that one will be 1 upon divided by 8.11. So this one. Some are direct questions and some are not direct. Some and some questions you need to work. So the next question here is that beta distribution. Beta distribution. So what is beta? Sorry, beta distributions PDF is given by 1 upon beta alpha comma beta. This is capital and x to the power alpha minus 1, 1 minus x to the power beta minus 1, and x is in between 0 to 1. So alpha comma beta are greater than 0. So beta alpha comma beta is defined as alpha comma beta is equal to, I think it's gamma alpha plus beta. So it is gamma alpha plus beta divided by gamma alpha gamma. So this is its PDF. So what is given here is that it is a random variable with alpha is equal to 2, beta is equal to 3, and maximum time to complete a project is 2.5 days. Now we need to find that what is the probability that project requires more than 2 days to complete. So x greater than uh, it is 2.5, so x will be greater than 2 divided by 2.5, so it will be 4 upon 5, which will be zero point 0.8. So this one will be zero point 0.8, x greater than zero point 0.8. Now zero point 0.8 we have fx, so it will be 0.81, and let's just find this here. So it will be gamma 5, and gamma 5 divided by gamma 2, gamma 3. So gamma 2 will be 1, gamma 3 will be 2. So we will have, and gamma 5 will be 4 factorial. So it will be 4 factorial divided by 1 factorial into 2 factorial. So this one is 24 divided by 2, that one is 12. So this value will be, so I'm sorry, it is 1 upon beta. So 1 upon beta will be 12. So beta alpha comma beta will be gamma alpha gamma beta divided by alpha by beta. So 1 upon beta alpha comma beta will be 12. Now x to the power alpha minus 1 is x to the power 1, and this one will be 1 minus x square. So now this is a simple integration. 0.81, 12 is constant. It is x 1 minus x square. So it will be x plus x cube minus 2 x square dx. So it will be 12, and then for x it will be x square upon 2. X cube will be x to the power 4 upon 4 minus 2x cube upon 3, 0.821. Now you can solve it, you can put the values. It will be point 0.027. This is also not an option. So you can solve it and you can check whether it is an option or not. But this is the way to solve it. So, okay. So next what we have given here is that we have a random variable x, and it follows beta distribution, beta alpha comma beta, and the mean and the standard deviation of x is given as 0.09 and 0.03. So if x follows beta alpha comma beta, then its mean expectation of x is given by alpha upon alpha plus beta, and its variance is given by alpha beta divided by alpha plus beta whole square, alpha plus beta plus 1. So all you need to do is that put the value as 0.09, and this is as 0.17, 0.173. No, this is square, so this will be 0.03 times 0.03. So it will be 0.0009. Standard deviation we have given here as zero point zero 0.03. So variance will be 0.0009. So what you can do is that you can take its square. Anyway, I will solve it in the next question. So this is also a similar question. We have here is that mean as 2 by 3. So alpha upon alpha plus beta is 2 by 3, and alpha beta divided by alpha plus beta square, alpha plus beta plus 1 is equal to 1 upon 8. So what we can do here is that we can take a square, alpha plus beta square, and we can divide it, so it will be 4 upon 9. So this one will be cancelled out, alpha will be cancelled out. So what we will have 9, 2. So here we will have 1 upon 8, I think, is equal to beta upon alpha, alpha plus beta plus 1, right? So from here we will have equation as 3 alpha is equal to 2 alpha plus 2 beta. So alpha is equal to 2 beta, right? So we will put alpha is equal to 2 beta. It will be 1 upon 2. It will be 3 beta plus 1, 1 upon 8. So this will be cancelled out. Ultimately, we will have 3 beta plus 1 is equal to 4. So beta will be equal to 1 and alpha will be equal to 2. Now we want to find the probability from 0.2 to x 0.5. Probability that x is greater than 0.2 to 0.5 will be 0.2 to 0.5. 1 upon beta, so 1 upon beta will be gamma alpha gamma beta divided by gamma. So alpha and beta are 1 and 2. So it will be gamma 1, gamma 2, 1, and then it will be times x to the power alpha minus 1. So x to the power alpha minus 1 will be 1, x to the power 1, and x 1 minus x to the power beta minus 1, so 1 minus 1 will be 0. So we will have 2x, so 2x will be x squared, uh, 0 0.2, 0.5. So now it will be 0.25, it will be 0.04. So this will be the. Is it okay till now? So we have 2 more questions left. Now this is, I don't know whether you have studied or not. But Sir has completed this up to week 4, so I will continue that. So it is given here ZT is equal to zero point 0.5 plus 2. So now ZT we have a function given as mortality rate. So what is that? We try to find there is a reliability parameter and that one depends on this rate. So what is reliability parameter? That means how much a machine is reliable. Now here it is depends on what will be the age basically. So reliability. So reliability RT is basically e to the power minus and 0 to t or whatsoever. Like if t is greater than 10, then it will be 10 to t zt. So if you have any question like this, then what we do is that this is rt. This rt is probability of x greater than basically. So now what we have here is that zt is equal to zero point 0.5 plus 2t. So firstly we will find rt. That means probability of x greater than t, because at last what we need to find, if baby survives to age 1, what is the probability that it will survive to age 2. That means if px greater than 1, what is the probability that px greater than 2. That's so this type of question we did earlier. So now we will find rt. What it will be? It will be e to the power minus 0 to t. Zt is zero point 0.5 plus 2t, right? So now it will be minus zero point 0.5 t plus t square 0 to t. So on putting 0 it will be 0, on putting 2t it will be, so it will be e to the power minus zero point 0.5 t plus t square. Okay, this is rt. Now Now what it will be? We need to find the probability x greater than 2 given x greater than 1. So x greater than 2, because when it is greater than 2, it greater than 1 already here. So there is nothing to take the intersection. Okay. So it will be r2 divided by r. So r2 will be e to the power minus 0.5 times 2 plus 2 square divided by e to the power minus 0.5 plus 1. So it will be e to the power minus 1 and then 2 square 4 and then 5. Okay, and this is 1.5. So ultimately it will be 3. So e to the power minus 3.5, you can calculate 3 is 0.03. So 0.03. Now this is the last question. Uh, so given here is that calls to a customer care number follows a Poisson distribution with mean 25 calls per minute. What is the mean time until the 100th call? So let x denote the time until event. So what happens that when we do Poisson distribution in this way, and then we want to find that any rth event occurring of any rth event, then what happens is that x follows gamma distribution. So that x follows gamma distribution. The mean time of call, that will not be a gamma distribution. Uh, so, but if you want to find the event occurring, that means if you have that, like say 50 calls, probability that 50 calls received or something like that, then it will not be a gamma distribution, it will be a Poisson only. But if you need to find that mean time until the 100th call, then x will follow the gamma distribution according to the definition, according to this definition. So when we have gamma distribution, so gamma distribution's mean is r upon lambda. So r upon lambda uh, will be 25 and lambda will be 100. Sorry. R will be hundredth event, and mean given here is that 25. So it will be 4. So the mean time until the 100 call, expectation of x, that will be equal to this. So we have this many questions. Now if you have any doubts regarding this, or if you have any doubts regarding the assignments you had submitted already. Uh, you may refer to book if you want. Then also you need to go through each and every topic. Otherwise, the sir has taught everything, and then I have notes, like I have done this course previously. I think 3 years back I did this course, and I have made the notes from that only. So you can make notes on your own. Otherwise, you can get it from the book. Okay, I'll try to make the PDF, but otherwise, if there is some clumsiness, then you need to audit it. Uh, yeah, yeah, okay. But I can share this notes. I can make the PDF, but it will be better for you to go through the lectures, because what happens is that you sir will teach you one distribution and then he will give you two three examples. So what happens is that that formula automatically you will understand that how to use it, when to use it. Otherwise, oh yeah, then you can ask me. Na, I'm here for that. Just write down the notes where you have problem and then you can ask me. It may happen that I also don't know. Then I can write it also and then I will explain it in the next class or maybe in that class. Okay. So okay. Any other doubts? Yeah. Huh. I think you can just do one lecture and then you will understand it by yourself. Because uh, I personally don't do all the lectures. I don't go through all the lectures and then YouTube sessions and all. I just feel that whatsoever is important, then I make questions based on that, and then I give it to you. So you can do it with one lecture, and then you will understand. And if you have still doubt, then you can write a mail to NPTEL, and then they will tell you. I think questions can be different, of course, but the like main topic will be from the swim itself. That's why you are doing the course, right? Okay. Any other questions or queries? Okay. So okay, thank you everyone for joining the course. Yeah. Let yeah. Yeah, you must have the access of all these things. Uh, there is a link given already. I will show it to you. You have this page. Do you have this page? If if you have filled, I think if you have enrolled in this, then you must have this. Yeah, okay, it is not presenting. Just present my screen. Entire screen. Uh, right. If you have this, do you have this access to this kind of page? Yes, and then if you will go to like any link, uh, let's say let's say this. Yeah, I don't remember the password, but yeah. Then here problem solving session, you know that, right? If you click on this link, then you will get these lectures, recording, and everything. I will do that later, but from there you can get all these things, this recording and everything, notes. Okay, so now I'm